dear colleagues. The topic of our report is educational technology for the formation of project competence for engineering students. The needs of the modern world require producers and consumers to switch to materials, resources, and technologies that reduce the burden of the environment and human health. Almost 10 years ago, the United Nations Organization formulated 17 Sustainable Development Goals to be achieved by 2030. The goals were subsequently structured around four main types of sustainability: human, social, economic, and environmental. In turn, socioeconomic changes impose special requirements on engineering education. Multidisciplinary learning comes to the fore when the learner simultaneously and synchronously acquires skills and abilities to fulfill human, social, economic, and environmental tasks. It requires the simultaneous development of three main components of professional activity: creative, scientific, and technological. The creative component is oriented to achieving human and social goals of sustainable development. The development of the scientific component is closely related to the economic aspects of sustainable development, which consist of innovation, the financial income of companies without harming the environment, and other. The technological component is based on the development, production, and processing processes of products and industrial waste. Accordingly, the environmental tasks of sustainable development are primarily related to technologies, their development level, and specialist training. The synchronous development of these main components of professional activity is a complex problem. So the goal of our research is to develop a technology for the organization of experimental training to form project competence using the project method in the conditions of the ongoing educational process. So an educational organization, PGBL works, created a comprehensive model and formulated 7 primary project design elements known as the golden standard of projecting. The idea of familiarizing students with the 7 golden design elements and mastering them in implementing projects developed personally is the basis of the educational materials in the experiment. So you see these 7 elements. Next slide demonstrates you survey methods that were as follows: determination of the main elements of the design project, determination of learning styles according to the Felder-Salomon method, survey of students after each stage of work, and some of statistical methods. The main tasks of statistical research were as follows: to determine the reliability of scale of the developed questionnaire used in the work. Such analysis allows to assess the reliability of the test with a single application and measures the internal consistency of the survey. Determine the nature of the distribution of variables, which allows you to determine representative indicators for the sample. To determine whether the difference between the sets of answers of the group of respondents at the stage, both of stage of experiments, is statistically significant. The answer to this question, in turn, allows us to assess the effectiveness of the proposed teaching methods quantitatively. Next slide demonstrates you the scheme of the experiments. The proposed scheme of the experiment includes 3 main stages. Students in the 4th year of Faculty of Fashion and Arts of Kyiv National University of Technologies and Design participated in the experiment. First, we determined the level of student knowledge regarding PGBL at the beginning of the experimental study. Students studied the basic concepts of problem-based and project-based learning. Before this lecture, students hadn't met using any projecting. Then there was a survey of students with the help of questionnaire specially developed by the authors to assess the initial level of knowledge. The second formative state included experimental training using the developed methodology to mold students' project competence. The technology is based on a short-term training course, you see this volume, organized as an academic model, and incorporated into the active discipline. During training, students independently choose a project topic from waste management, develop, execute, and defend it. The third stage aims to assess the effectiveness of the experimental training. For this purpose, the results of surveys after the first and second stage were compared. Individual learning styles of students were also determined using the Felder-Salman method. Determining students' preferred learning styles allowed one to reveal the existing educational advantages of the group. To see the example of this stage of the experimental training by PGPL, more detail, you can read information about this approach in our article. And the next slide demonstrates a scheme of study of individual elements of the project design at stages from 1 to 5 of the experimental study. You see this circle with these elements. The proposed technology focuses on mastering the 7 basic elements of PGPL in abbreviation and in circle 2, which are considered indicators of project competence formation. An essential part of the module is the organization of regular and prompt feedback between students and teachers using short daily surveys via Google Forms. This tool allows teachers to adjust the training content and accent in time depending on each lesson's effectiveness. Next three slides demonstrate you results of our experiment. Comparison of the average scores of individual design elements based on the results of a certain informative experiment. You see the values of average scores increased after the respondents underwent experimental training for all elements without exception. Next slide demonstrates you the changing in places in rank for success for each of elements. They proposed and you see the difference between the results of formative and between both of experiments calculating in mean ranks. Statistically significant improvement was observed for 4 of the 7 elements. For the other 3, progress was also observed, but didn't exceed the 0.05 significance level. The general trend of progress in learning was that the more classes were devoted to one or another projecting element, the more remarkable improvement was observed. In other words, minimal but sufficient attention to each element is necessary for achieving progress in its study. The SI sustained inquiry element in the development model wasn't given enough attention, so this element ended up in the last place in the progress rating. But you can see maybe the numbers of lessons, but different success. So progress was less than expected for 2 elements, which received quite a high level of attention during training. The non-ideal organization of project learning and the unaccounted feature of the students' learning style inhibited the mastery of some design elements, namely critical and revision, CR, and RT, reflection, and thoughtfulness. Mastery of CR element includes active discussion among all participants. However, the chosen format of individual projects wasn't entirely favorable to broad discussions, limiting the possibilities of exchanging ideas in contrast to group projects. Accordingly, implementing group projects should contribute to a better understanding of the CR element. Studies of learning styles have shown the advantage of students' successive styles of information comprehension over a reflective one. Most students preferred an active learning style compared to a reflective one. Developing reflective thinking is vital for mastering the RT element. This factor has become the reason for slowing down progress in mastering RT. The development of reflexivity due to the implementation of the proposed special exercises in the educational process is promising for eliminating the identified deficiency. Next slide demonstrates your conclusions and prospect for future research. The developed educational technology isn't limited to the studied topic and has the potential for future development and explanation. Subsequent studies will aim to eliminate the identified shortcomings. Thank you for your attention.